All right, hello everyone. Thought I'd put up an example of solving a full triangle using SOHCAHTOA. So, here's a good example of a problem. We have some unknowns, we have some givens, and I'm just going to kind of show you one or two ways to get through a problem like this. What's the thought process? Like, what am I supposed to be doing while I'm looking at a problem like this? So the first thing that I want to do is draw my triangle, all right? If I don't have my triangle correctly, then I'm probably not going to do any of my calculations correctly. So I'm going to start with my reference triangle, and I'm going to start filling in some values if I know them. So side A is unknown. Side B is going to be 12. All right, side C, which is our hypotenuse, that's also an unknown. And remember, when you're labeling your angles, this is where a lot of people were making mistakes. Remember, the side is going to determine the name of the angle. So angle A belongs here because angle A, all right, is opposite side A. All right, and that's always going to be true. Angle A is always going to be opposite side A. All right, and the same thing with B. All right. Angle B is always going to be opposite side B, all right? Or we should really say side B is always opposite angle B, all right? And so the other thing that we know here is that angle B is going to be 32 degrees. Now this is a great example of a problem where you don't have a whole lot of options. In a lot of the other examples that we did in class, we saw that the first thing that you could do is go right at the Pythagorean theorem. But we can't do that in this case because, as we're looking at this problem, we only have one of the three sides. We only have side B. And for us to be able to solve for one of the other sides right now, A or C, we'd have to know at least one of them. All right, so you can't have one equation like A squared plus B squared equals C squared and have two things that you don't know in it. So we don't make anything up. We don't come up with something like this total garbage. We just can't use Pythagorean theorem to start here. And so that forces us into the situation where we're going to have to do some kind of trigonometry. Now, I'm going to pick the low-hanging fruit to start. Okay, one of the things that I see here is that I do know angle B. And I also know that angles A and B need to add up to 90 degrees. Remember, there's 180 degrees in a triangle. And so that means that angle A plus angle B needs to equal 90. So angle A plus angle B should equal 90 degrees. And if I know that angle B is 32 degrees, then that must mean that if I subtract 32 from 90, right, which is going to be 58 degrees, then that should be angle A. So immediately, I found another piece of information. I know that this is 58 degrees. Now that does ease things up a little bit because now I have two angles to work with. But I'm going to stick with angle B up there. All right, and that's the thing. We want to always look at the angles when we're dealing with trig functions. The angle is going to help me know whether or not I'm using sine, cosine, or tangent. All right. Now, all right. I know angle B. That's a given. All right. Angle B is a given. That's 32 degrees. Okay. I also know side B. All right, that's 12. So those are two given pieces of information. Now, I should be able to use these two things to solve for either side A or side C. And those are my two leftovers, all right? In fact, I'm going to do both of those with trig functions just because I can. So let's start with side C here. Side C is always our hypotenuse, all right? So I have a hypotenuse. That means I'm either using sine or cosine. And then I have to look at the sides that I know. Well, I know side B over here. And if I'm looking at angle B, right, which is right up here, then I look at these and I say, all right, side B is opposite angle B. So I have an opposite side, side B, and I have a hypotenuse side, side C, opposite and hypotenuse, that's automatically going to be sine. right? So sine of theta is opposite over hypotenuse, all right? And so if I go to start to substitute my values here, if the angle I'm talking about is angle B, then it has a measure of 32 degrees, all right? And if side B is my opposite side, and it has a value of 12, I'm going to substitute that for the opposite side. And the hypotenuse is C, that's my unknown, all right? So essentially, this is just like one of the first three examples that we did, where we used sine, cosine, and tangent to solve for a missing side. All right, now this one is one that has the unknown in the denominator. And we know that we can't leave those variables down there in the denominator, so we need to multiply by C on both sides to get it out of there. All right, now that leaves us with C times the sine of 32 degrees. All right, and that's equal to 12. That's what left on the right side of the equation. Now, sine of 32 degrees is a number, all right? We can calculate that in our calculator. Remember, sine is a function, so that when we plug a number into it, that's our input, which is 32 degrees here, then we should get an output that is what we would consider the sine of 32. And the sine of 32 is something like, all right, 0.5299, all right? Now those decimals go on for quite a while, but 4 or 5 decimals is definitely good enough to be able to solve this. So we have C times this number. We still are solving for C. That means we need to get rid of that 0.5299. And the only way to do that is to divide on both sides, all right, by 0.5299, all right? So they cancel out on the left side, and that leaves us with C is equal to, remember, 12 divided by 0.5299 is, all right? And when I punch that into my calculator, I get a side C of 22.65, all right? So 22.65 is now side C, 22.65. All right, so that's now a given, or it's a known value, and I could use that to solve for side A. Maybe using the Pythagorean theorem, that could be a choice right now. Instead, I'm going to use a different function, all right? I calculated the length of side C, and if I did it wrong, then if I use that in another calculation, it's going to make my next calculation wrong too. So I'm going to try to avoid that, all right? So what I'm going to do is I'm going to stick with angle B and side B here. But I'm going to use a different function to solve for my last unknown, which is side A, all right? So if I'm looking at angle B here, side B is still opposite, all right? So I still have an opposite side. But side A here, that's adjacent to angle B. So I'm all doing it from angle B here. So angle B is right up here, okay? Side A is adjacent to it. Side B is opposite. So opposite and adjacent, that is going to be tangent, all right? So tangent of angle B should give me, which is my opposite over my adjacent side, all right? If I substitute my values, I'm using angle B up here, angle B, which is my 32 degrees again. My opposite side is 12, all right? And my adjacent side here is now side A, all right? Now look at the math. It's the same as what I did with sine over there. So I'm going to multiply by the A again, all right? That's going to cancel that out. And I'm going to show you something a little different here. You see, tangent of 32, this is just a number, all right? We calculated in the previous example for the sine, but we don't always have to do that. We could punch this into a calculator all at once. So over on the left side, A tangent of 32 degrees is equal to 12. What I can do is I can just divide by the tangent of 32 degrees on both sides. And you can just punch that into your calculator if you wanted to. So instead of getting the decimal and then dividing by the decimal, we could just do it all at once in the calculator by punching in 12 divided by the tangent of 32. All right, and in this case, I get a value of 19.20. All right. And so that's the end of the problem here. We see that there are a lot of different options as we went. We didn't have to use tangent here at the end. We could have used the Pythagorean theorem, a squared plus b squared equals c squared. We could have even used angle A at some point, the 58 degrees, if we wanted to. It's just that this was the path that we chose to go through it. So this is solving a full triangle using sine, cosine, and tangent, and the Pythagorean theorem. All right, so this is our first example. I'm going to stop the video here.